This video is to help you review for the Unit 5 quiz. Remember, again, these will be the types of questions that you would see then on the quiz. So the first question has to do with multiplying integers. Find the value of 9 times -3. So positive 9 times a -3 is -27. Next question is to find the value of -3 times -6. Remember, a negative times a negative is positive, so it's positive 18. The next one is addition. So if you have -13 and you're adding -5 to it, again, you can think of it as 13 negative integer tiles, adding 5 more negative integer tiles, or you could think of it as starting at -13 on number line, going back 5 units to the left. Either way, you end up at -18. Next one, if you have -50 plus 9, again, you could visualize 50 negative tiles, 9 positive, they'll make 9 zero pairs, or you could picture it as finding the difference between the two of these since they're opposites, and then carrying the sign of the value that's further from 0 on the number line, meaning negative. So these are opposites of each other, so you're going to create 9 zero pairs, and you're going to have 41 negatives left. We'll have to work a little more with diamond problems. Again, remember the top always means the product and the bottom is the sum. So you should have that in your workbook as well. They won't always indicate it to you, so you need to make sure you know it. So we're looking here for what value you add to 14 to give you 6. Now you might say, well, add to 14 to give me 6. Well, again, this is going to have to be a negative value that we're going to be adding, because how do you go from 14 to 6? Only by adding a negative. So it's going to be -8. If you have 14 and you add -8 to it, you're going to get a positive 6. Then what is 14 times -8? Well, negative times positive is negative. And 14 times 8 would be 112. For this one, you're saying to yourself, what two values will add to give me -3 and multiply to give me -28? Now, again, you might go, well, I don't even know where to begin with that. Think about your values, your factors of 28. So one's going to have to be positive, one's going to have to be negative, but there's not that many factors of 28. So it could be 28 and 1, where either this is negative and this is positive, or the other way around. Okay. It could be 14 and 2, again, with one being negative, one being positive. It could be 4 and 7, one being negative, one being positive. And that's basically it. So one of these combinations will have to equal -3 when you add them. And hopefully the one that jumped out to you, the correct one, is this one. 4 and -7, and the order doesn't matter, so you could put the 4 here and the -7 here, or you could switch them. But those are the two values that will add to give you a -3 and multiply to give you a -28. Next type, Vic has 3 dress shirts, blue, brown, and red. He has 2 dress pants, tan and black. He also has a striped and plaid tie. If he chooses his outfit randomly, what's the probability he's going to choose the blue shirt and the tan pants? So the first thing you want to do is to think about how many total options there are, which is that he's got 3 dress shirts times 2 dress pants times 2 ties. So you're going to multiply the possibilities to get the total number of possibilities. So the number of choices for shirts times the number of choices for pants times the number of choices for ties get multiplied to give you the total number of outfits. 3 times 2 is 6, times 2 is 12. So there's 12 options here, 12 outfits. What we want to know is, out of those 12, what's the chances he's going to pick the blue shirt and the tan pants? Well, the blue shirt is 1 out of the 3 shirts, and the tan pants is 1 out of that. But he could have that combination with the striped tie, or he could have it with a plaid tie. So in other words, if we picture this, in a tree diagram, or we picture a list, he could have the blue shirt, tan pants, and the striped tie, or you could have the blue shirt, tan pants, and the plaid tie. So there are two combinations that will include the blue shirt and tan pants, 2 out of the 12. Now you could make a list of the entire 12. You could have made, blue with tan with striped, blue with tan with plaid, blue with black with striped, blue with black with plaid, brown with tan. So you could list all 12 as well. That'd be another way to get the total number of possibilities. In fact, up here, I probably would have had room, could have listed them all or done a tree diagram. So this is the counting principle. It's a way to get to that amount, but you could also get the list to get that total. So 2 out of 12, though, would then simplify to 1 out of 6. And then if he chooses his outfit randomly, what's the probability he's going to choose the blue shirt, the black pants, and the striped tie? Well, that particular combination, blue shirt, black pants, striped tie, is only 1 out of the 12. All right, and again, I want to be clear that you could also have listed all the possibilities up here, might make finding these probabilities easier. Amy reached into the bag, recorded the marble color she chose, returned the marble, and drew again. These are the marbles she chose so far. Red, red, blue, yellow, blue, red, green, blue, red. What's the probability her next draw will be red? So what we want to do is figure out how many reds she has. 1, 2, 3, 4, out of how many total times she pulled a marble out. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability that her next draw would be red would just be 4 out of 9, basing it on what she's already done, 4 nights. Then Amy reached into a bag, recorded the marble color she chose, returned it, drew again. These are the marbles she chose so far. What's the probability her next draw will not be yellow? So we can count up how many are non-yellow. 1, 2, 3, 4, 5, 6, 7, 8 are non-yellow out of 9. The other way we could have done that is said 1 was yellow out of 9. So that means, of course, 8 out of 9 would be non-yellow. Same concept again. This time, though, she's doing it 140 times, and we want to know how many times she expects to get red. So we have 1, 2, 3 reds out of 1, 2, 3, 4, 5, 6, 7. So there's 3 reds out of 7 total. So what we want to know is how many reds would we expect to get out of 140? So if we get 3 reds out of 7, how many? That's a question mark. This is kind of an ugly one. How many reds would we expect to get out of 140? So we can do that with cross products. We could take 3 times 140 and then divide by 7. You could say, what do you multiply 7 by to give you 140, which is 20, multiply 3 by the same thing. Either way, you end up getting 60 times. So we'd expect to get red about 60 times. Again, if you did that with your calculator and the cross products, that would be coming from 3 times 140 and then divided by 7. So there's our 60. Or like I said, multiply by 20 on the top, multiply by 20 on the bottom. Get to the 60 as well. There are 2 choices for an entree. Entree means a main dish at school. 5 choices for a vegetable, 4 choices for a fruit. If you choose one of each, how many options are there? So this is really just the counting principle. We don't even know what the different entrees are. We don't have to make a list. We just recognize that there's 2 choices for the main dish times 5 choices for the vegetable times 4 choices for the fruit. Okay, so I can put raised dots in here for multiplication, or I could have moved this in and shown that they're all being multiplied that way as well. So 2 times 5 is 10, times 4, there are 40 options. Again, that is the counting principle. How many choices for this times how many choices for this times how many choices for this equals total number of options. What is the probability of rolling 3 6s in a row on a die or number cube? Well, we know that 1 out of 6 on a number cube is a 6. All right, so on a number cube, we've got 1, 2, 3, 4, 5, 6. One of those out of the 6 possibilities is the number 6. So the probability of rolling 1 6 is 1 out of 6. But the probability of rolling 3 6s in a row means we have to take the probability of rolling 1 times the probability of rolling another. Oops, that's very messy, sorry. Times the probability of rolling another. So in other words, 1/6 times 1/6 times 1/6. So the probability of this and this and this occurring, whenever you want probability of this and this, you multiply. So the probability of getting 3 6s in a row is the probability of getting a 6 multiplied by itself 3 times. In other words, 1 6 times 1 6 times 1 6. Well, 1 times 1 times 1 is 1. 6 times 6 is 36. And 36 times 6, I feel like I should probably know it. I want to say 216. Yep, 216. So it's 1 out of 216 probability of getting 3 6s in a row. So very small probability. If you flip a coin, then roll a number cube or die, what's the probability of getting a tails and then getting a 3? Well, the probability of getting a tails, we know, of course, on a coin is 1/2. The probability of getting a 3 on a number cube is 1/6. And the probability of getting this and this is where you're going to multiply them. So 1/2 times 1/6 makes 1/12. If you flip a coin and then roll a number cube or die, what's the probability of getting a tails and a number less than 5? Well, probability of getting a tails is 1/2. Probability of getting a number less than 5. So what you want to do is think about how many numbers on a number cube are less than 5, which is 1, 2, 3, and 4. Those are all numbers less than 5 on a number cube. So that is 4 out of 6, or you could simplify that. But for now, we'll leave it as 4 out of 6 and simplify after. So the probability of getting tails is 1/2. Probability of getting a number less than 5 on a number cube is 4, 6. And then we're going to multiply those. Again, you can simplify before you multiply. So 2 divided by 2 is 1. 4 divided by 2 is 2. And you can simplify the 2 and 6 as well. As long as it's numerator with a denominator, it can be simplified. 2 divided by 2 is 1. 6 divided by 2 is 3. So in the numerator, we end up with just 1, and the denominator 3. So 1/3 probability of getting tails and a number less than 5 on a number cube. The sum of 3 consecutive numbers is 24. What are the numbers? And they want you to use the 5D process. So you're going to start with describe or draw. That's your first D, remember. So what is the basic critical information? 3 consecutive numbers, which remember means something like, 3, 4, 5, or 11, 12, 13, that kind of thing. All right, that's the idea of 3 consecutive numbers. And the other bit of information that's important is that the sum of the 3 has to equal 24. Oops, I typed wrong, sorry. The sum of 3 is 24. I think I'll put is instead of equals. So those are the 2 critical bits of information, and I guess I could make them into 2 separate lines here. Then what we're going to do is we are going to set up our define. So we'll have one number be x, the next number will be x plus 1, because it's 1 after, and the next number would be x plus 2. So that's how you get consecutive numbers. One number will be x, then x plus 1, then x plus 2. And then we have to, so we've described draw, we've defined, we have to figure out what we'll be doing. which would be to add them, right? We'll have to decide which is that they should equal 24. And then we'll have to declare once we find our answers. So you want to start with a guess of 3 consecutive numbers. So let's say you started with 3, 4, and 5. So when you add 3 plus 4 plus 5, oh my, that's a bit messy there. I'll try to do it with typing instead, make it a little easier to read maybe. So 3 plus 4 plus 5 would equal 12, which is too low. So then maybe we'll try something different. Maybe we would try maybe 8, 9, and 10, or 7, 8, 9. Again, you get to kind of play around with it a little bit. Let's try 7, 8, and 9. So 7 plus 8 plus 9. 7 plus 8 is 15, plus 9 is 24. So yay, that one worked. And remember, it won't always happen that quickly, but that is the idea. And then we are going to declare. So we will declare that the 3 consecutive numbers that add to 24 are 7, 8, and 9. Okay. So I'll put that up a little bit nicer there, so hopefully you can see it, but we'll have to do a little bit of 5D process. Another type, sum of 3 consecutive odd numbers is 87. What are the numbers? So again, you'll do your describe draw. We've got 3 consecutive odd numbers. Now, what does that mean? Bad typing again. Well, that means that the numbers are consecutive in that they're one after another, but they're only the odds after each other. In other words, it could be something like 11, 13, 15. Oops. Or put example in front of this. Or it could be something like, 20, 27, let's say 29, 31. That type of thing, right? So the idea is that they have to be 3 consecutive odd, meaning the next odd and then the next odd. That's considered consecutive odd, right? And then, of course, the sum has to equal 87. So again, you're going to go through your process. You're going to write down your, your define, which should be like x. And then this sometimes confuses people, but it's x plus 2. Now, the reason they say it confuses people is because they think, well, this is supposed to be an odd numbers. How do you get x plus 2? Well, keep in mind your first number, if your first number is an odd number and you add 2 to it, you're going to get the next consecutive odd. If this number is, let's say, 13, adding 2 will give you 15, adding 4 will give you 17. So if you want to go from an odd to the next odd, you're going to add 2. If you want to go from an odd to the next odd to the next odd, then you're going to end up adding the 4. That same thing is true with even numbers. But the key to it is that every other number is odd and every other number is even. So that is how you're going to define them. And again, you're going to do your Your do, what are we going to be doing to them? We're going to be adding them. And your decide, which is that they should equal 87. And then you're going to do your declare. Again, you will test and so forth. I believe, just from having looked at my examples, I am thinking that the 27, 29, and 31 might very well work. Let me try it. 27, the next one will be 29, the next one will be 31. So let me try adding those. Yep, that will equal 87. So, not always that fortunate, but that did work right away. So then the declare would be that the three numbers, consecutive odd numbers, are that add to 87 are, and then we would just list them. Uh, 27, 29, and 31. Now, the next part says what operation is the same as dividing by 3? Remember, the same thing as dividing by 3 is multiplying by 1/3. Just like taking 1/2 of something is the same as dividing by 2. Multiplying by 1/3 is the same as dividing by 3. So those are the types of questions to expect on that. Thanks.